Welcome to another episode of Coder Conversation. We have our special guest, Jim Armstrong. Hey, how's it going?
Oh, very good. Thank you very much for having me on.
Yeah, we're glad to have you on. Can you give us a little bit about your background? Like, when did you start coding and how did it lead up to your current position?
Ah, yes. We must go back many years into the dark ages before touch devices, before personal computers, when only cavemen like me wrote programs. I actually started on TI programmable calculators. Started college. I was in a technical program at the time, math and physics, which later on turned to math and aerospace engineering. I needed a calculator. So, man, I had some birthday coinage in my pocket. I went up to the store. I started looking at calculators. Of course, I went right to the most expensive. It was the super cool, programmable calculator. In fact, it was so cool, it had these magnetic strips. And you could take a strip and you could put it into a slot in the calculator and you could actually store your program. Now, the syntax was very crude. It was like a RISC assembler. That's the closest I could come. But it was so cool to be able to use a calculator for something other than just adding numbers together and doing trigonometric functions and all of that. I could actually write something that approximated code with it, and I could take repetitive calculations. I could store them in this little mag strip, and that was like just super cool. Well, that led me to wanting to take a more formal programming course. And since I was in a technical discipline, Fortran seemed to make the most sense. So I took this Fortran course. And the professor who taught the course was also a math instructor. In fact, one of the few people that was interested not only in theoretical math. I took a theoretical math course from the same instructor, but he could program computers. And it was really interesting because at the time it was a state of the art Burroughs mainframe, and it had this system called Candy, which is short for command and edit. So I, instead of working with card decks, which I did have to do later on in my college career. At least I got to start off with this like really nice monitor, and you could store your programs on disk and so forth. So during the course of this Fortran course, the instructor became very enamored with the game of Nim. It's a very simplistic game. It's played with sticks and laying sticks across rows, and something about forcing your opponent to have to put the last stick down. That's all I remember. That this is like circa 1978. I don't remember things that well anymore. Uh, but he issued a challenge in class. He says, "Okay, I've been studying the strategy for Nim, and I have proven that there is an optimal strategy, and if you're the first one to play and you play optimally, you should win every time. So I'm going to offer that anybody in the class who wants to create a program that will play Nim, and if it can beat me 80% of the time if it goes first, and if it plays me a very tough game when I go first, you get an A in the course, no matter what your current grade is, and you don't have to take the final exam." So, how many people think that I took that challenge? Yes, I did. So, I eventually wrote this Fortran program that played Dim. And it actually did a little bit better than he expected when the computer went first. Of course, the runtime with this candy system was very interesting because you could pause execution and take in user input. And again, go back to about 1978 or so. That was insane to be able to do that, especially with a Fortran program. And so I wrote this program that beat him 100% of the time when the computer could go first, and it played him a very tough game when he got to go first. And so, yes, I got my A, which I was thankful enough I had an A going anyway, but at least that was one less final to take. But what I took away from that experience was, here is a way to take math that I already know and combine it with something that's completely new, computer programming, and I can now interact with people in a way on a screen that I could never do before. And that was just really, really intoxicating. And as my college career went on, I switched to math and aerospace engineering. I kind of specialized in numerical analysis and computational geometry. And I spent all my time in the computer lab just writing these insanely complicated computational geometry codes and drawing all sorts of incredibly complex stuff on the screen on a Tektronix graphics display. And that whole idea of being able to combine these two things that at least at first seemed very separate, that is, mathematical models for physics and engineering and business processes with this thing over here called computer programming, and being able to somehow put the two together and interact with people in amazing new ways was just intoxicating was the only way I could describe it at the time. So that's what really, I was never interested in programming and development for the sake of development. It was a means to an end. And that end was to apply mathematics in completely new and different ways. And so it was a very formative experience in my college years that I was very lucky to continue doing, throughout my professional years and even now in retirement.
So your journey also led you into the game industry. Is that correct?
I actually never worked directly as a game programmer.
Hmm.
It was one of those things that never seemed to up. Now, there was a time when I started my own business in 1997, I did 3D modeling and animation. And I also did plug-in development in 3D Studio Max.
Hmm.
And one of the first plug-in gigs I had was working with a local game company. Now, way back in the day, keyframes were expensive. Remember, these are we're still in the caveman days. Now, the cavemen have graduated to where we have personal computers, but not everybody has broadband. A lot of us are still dialing up on. It was a big deal to have like a 900 or 1200 baud modem. And instead of the text going across the screen like this, it went across the screen like that. And so if you're trying to ship a game update, keyframes are insanely expensive. So forget mocap and all that cool stuff we do today. It was all about IK, forward and inverse kinematics, and IK being the more difficult. So the thing is, the animators would do things like animate a waltz cycle or a character responding. All these predefined animations would be done in like 3D Studio Max. But then they were implemented in the game engine. And in the game engine, you have fixed number of time slots for doing you have a time slot for AI, you have a time slot for texturing, you have a time slot for rendering, blah, 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 on and on and on. It means you have a time slot for IK. So as it happened, they used a different IK solver in the game engine than they did inside 3D Studio Max. And so the animators are getting all pissed off because my walk cycle doesn't look like I animated in 3D Studio Max. And so this was at a point in time before the game industry discovered that, hey, instead of working people 60 hours a week, we can work them 90 hours a week. And so they actually called in an outside consultant, says, hey, can you sit down with our game engine guys and find out, what IK solver are they using? And I want you to write a plugin that does that in 3D Studio Max. So that was the first plugin I wrote in 3D Studio Max. And it was the closest I got to being in the game industry. But thankfully, I never had to put any of those, 90 or 100-hour weeks in. So maybe it was a good thing.
Yeah, can you tell us about some of the other interesting projects that you worked on throughout your career?
Well, first, let me tell you about something that was also I've actually got three for you that I'm going to go through. But I want to talk about something else first because I think this is something that I can pass on to a new generation. And it's a phrase that I came up with, and I think it's due to me, but I'm not exactly sure. It was at a point, at the end of my college career where the big thing in business was, ooh, think outside the box, right? People get boxed in or constrained by the sum total of their, expertise and experience. But to me, think outside the box meant just move the boundaries of basically think outside the box, just expand the box. So I had this phrase that I came up with, and it was from a foundational experience in my dynamics of flight class of Dr. Fairchild. And it wasn't think outside the box, think outside the world that contains the box. And this came up when we were just finishing off our derivation of Euler angle equations for modeling an airplane. And so Dr. Fairchild pointed out, what people in inverse kinematics, I already mentioned that. A lot of the old IK solvers, they used Euler angles for their model in inverse kinematics. Well, in an airplane, when the plane goes up to a vertical angle of attack, the denominator in the Euler angle equation model goes to zero. In math, we call that a singularity. And so there was this real famous thing called the Euler angle singularity. But Dr. Fairchild made this comment. He said, well, now, here's what I want you guys to think about for the next class. And that is, we've already shown that this is an accurate model for the motion of an airplane, and that we watch airplanes all the time. You can't go through a barrel roll without going through a vertical angle of attack. Does anything happen to the airplane? Does the space-time continue and break down? Does the airplane blow up? Does it blink out of existence real quick and then come right back? Well, no, it doesn't. And so I noticed he did something very strange. He says, I want you to think about this equation and that observation. And he was taking his fingers, he was almost hammering the board on the numerator of the equation. And so, of course, if he issued a challenge, I'm a young dumbass. Of course, I'm going to do it. I'm going to ignore all of my other schoolwork, and I'm just going to work on this one thing. And so I spent like a day on it, and I just couldn't come up with anything. It's just like every time I looked at it, the derivation is right. These are the right equations. But I kept thinking, why was he tapping away on the numerator of that equation? Well, let me see what happens to the numerator for a vertical angle of attack. It goes to zero as well. So you don't have a singularity. It's in a limiting form. It's 0 over 0. We call that an indeterminate form. So the equations aren't singular. They're indeterminate. Oh, calculus 3, indeterminate form, L'Hopital's rule. I took the derivative of the numerator, divided the derivative of the denominator, and boom, it worked. So you have to switch over to a different form of the equations when you're very close to vertical angle of attack. Same thing, and this is what in inverse kinematics leads to bone rig, right? You're moving the end effector here, and you get it out like this, and all of a sudden it pops, and then it comes back. That's not accounting for that singularity. And of course, eventually people discovered that quaternions are a much easier and more elegant way to model this type of motion. They don't exhibit that indeterminate form. There's no need to switch the equations, blah, blah, is solved. But to me, the way of thinking about problems and that solution is what just completely changed my mentality. And I think it's probably been the hallmark of my entire career. I'm not a developer. I don't mind saying that. I'm really not. There's a lot I don't know about software development. There's a lot I don't know about mathematics, but I have a very particular way of thinking about problems. And I'm going to give you three examples. And if it gets too boring, cut me off or whatever. One was my first big job out of college. I started it immediately writing assembly language math libraries for supercomputers. And, we have all of these verticals that we're selling in. And we sold what was known as a vector machine. It's a VLSI pipeline architecture. So you're not dealing with scalars, you're dealing with vectors. And the thing that I learned right off the bat is that it's all about memory. Forget everything that you know about big O, little o, and medium size O. Those are important concepts at a very high level. But when you get down to wall clock time, how fast do things actually run? It's all about memory. And so one of the problems I got thrown into was fast Fourier transforms. And a fast Fourier transform is nothing more. Discrete Fourier transform is n squared. Fast Fourier transform is n log n. But it only works if the transform size is a power of 2. So, if we go back to my caveman days, people have constantly been gathering in signal data where the sample sizes are power of 2 so they can use the fast Fourier transform. FFTs on vector machines have two problems. One is vector length, and the other is memory access. In order to get memory to keep up with the compute capability of the machine, we didn't have cache. It's not a modern microprocessor. We had interleaved, and memory was separated out into 4 banks. So dynamic RAM has to spin up for a few cycles before you can get something out of it. So by having interleaved memory, we could run one chip inside each bank simultaneously. So after the spin up time, in one clock, we could get result, 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 result. So arrays, for example, were stored serpentine across these banks. So the first array element was in bank 0, the second array element bank 1, third element bank 2, blah, 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 blah. So what that means is that in terms of memory access stride, unit stride is optimal. Odd stride is good. Even stride is bad. Well, what does the classic FFT algorithm have? It has log n passes of length n, but you're working on chunks of the array, and the vector length of the chunks go down by a factor of 2 each pass. Bad news. Second problem is if you restructure the computations to do something like they used to call it constant geometry. You can get consistent vector length, but you have power of 2 memory access. So we're getting killed by this because things are running slower than they need to, or they're running inconsistently. And it was even worse when we came out with our second generation machine, because our first generation machine was not truly 64-bit. It was 2 30-bit vector pipes, 32-bit vector pipes operating on a half cycle. So from there, you could synthesize a 64-bit result. Then what that meant is that 32-bit single precision, which is what FFTs are done in, ran twice as fast as 64-bit. We go to the new generation machine, it's a true 64-bit architecture, 32-bit and 64-bit run pretty much the same. So we get a factor of 2 to 2.5 from the new generation machine, only if you're comparing double precision to double precision. Single precision to single precision, no, that's major suckola. So I was like under the most enormous pressure because we needed that factor of 2 back. And so I sat down and just started really thinking, okay, what can I do to solve these two problems? One problem is actually easy to solve, and that's the decreasing vector length. As you go from pass to pass to pass to pass, when you get down to your register size, which is 128, reverse the loops. It's like Doctor Who used to say, you reverse the polarity of the neutron flow. Just reverse the loops. Now the vector length starts going back up. Yay, that's good. But what's bad? You have power of 2 stride. So we have decreasing vector length, but unit stride. Then we get down to a vector length of 128. We reverse the loops. We have increasing vector length, but the stride is going up by a power of 2 each pass. So remember, this isn't just to think outside the box. Think outside the world that contains the box. Okay, if it's all about memory, I finally figured out one day, it's my memory. I control it. I'm the assembler programmer. I can do whatever I want to with that memory. So I came up with this clever way of when we did the loop reversal, I didn't put the result of the computation where it was supposed to be. I stored it in some completely different order. And then I made up for that as a correction the next pass. And it was amazing because I can't remember which one is which. We had, I think it was like odd stride access in the store, followed by unit stride access in the load. So simultaneously, just by doing that one thing, I solved the vector length problem and the stride problem simultaneously. Furthermore, instead of doing one pass at a time, I did 2 passes at a time. So instead of load, compute, store, I did load, compute, store. So the FFT went from being memory bound to being compute bound. Especially for large transforms, that got our factor of 2 back and even more. Now it was a bear to write. It was about 20,000 lines of assembler, and it was not easy to write, but I made it through that. And the crowning achievement was when a foreign government friendly to the U.S. came in, and they did this incredible. I never seen anybody do a benchmark like this. We had to set up a room that had 3 different access levels. To get into the first room, you could be an employee, but you had to be pre-approved by this government. To get in the second room, you had to have a secret clearance. And to get into the third room, you had to have a top secret. So we only had like 1 or 2 people in the entire company that could go all the way into the third room. That's where the machine was located in order to do this benchmark. I found out later they were testing, and this is circa 1987. They were testing 2 million point transforms on my FFT, and we were competing with a Cray supercomputer at a tiny fraction of the cost. So that was, one example of don't think outside the box, think outside the universe that contains the box. Another one, which I'm not going to go in the story because I know I can see the people out there asleep right now, was when I was consulting with the Sabre Research Group, and I needed a mechanism for visualizing sparse matrices, but in their original dense form. And it needed to work cross-platform. So I came up with a way of, I wrote an add-on to the solver library in C++ that output dynamic HTML that allowed me to interactively browse these blocks that comprise the entire matrix. And we could use Internet Explorer 4, which had just been released on Unix, and we could go in and look at the assembled matrix in its dense form. And typically you click on a general sparse block that had a C++ class associated with it. We'd use reflection to look up the class, dynamically instantiate it, blah, blah, blah. And we'd look at it, go, and one of the, the modeling guys in the research goes, wait a minute, that value there is not supposed to be negative. Oh, well, I know what class generated that block. Now we know where to go set a breakpoint. We run it through the debugger, step through, and we find out it's either a bad value from the database or they also have problem with duplicates. And so we would load things up in C++ STL maps, which is a sorted associative container. And so maybe you concatenate DFW and BOS together for the DFW to Boston leg, and there was some physical value. Maybe it was number of pounds of fuel that was needed. And so we would find that the DFW BOS value would come in correct, but if we ran through the entire loop, later on there'd be another DFW BOS and it would have a negative value. That's where the negative value came from. And that was huge. Again, thinking outside the world that contains the box. Use dynamic HTML and IE4 as a means to interactively visualize sparse matrices, but in their dense block form, and something that worked on Windows NT workstations that we used in the research group, as well as the Unix systems that the production guys did. And so again, that was just a way of thinking about solving a problem using technology and expertise that I had that it was actually kind of considered quite revolutionary at the time. I think I'm probably the only person that has ever used IE and dynamic HTML for sparse matrix visualization. Probably the third one, and I would say this is the most interesting one, was this was actually in Flash, back in my Flash days in the mid 2000s. And I was working with an advertising agency down in Houston. Well, they had a client, it was ExpressJet, and they had the print and video piece of a new campaign. And the campaign was centered around the fact that at the time, most people thought that ExpressJet didn't fly many places, but they really did. And so this route map was like the centerpiece of their campaign. Well, they already had an agency that they used for interactive. And they had a requirement that they wanted this route map, they wanted the arcs to be animated out. So when the page came up, you'd see this, these route arcs just kind of explode out from origin to destination. But they wanted it to be data driven because they're expanding, and like many other carriers, they had some seasons where they didn't run particular flights. So they wanted to be able to interactively take routes out, put new routes in, and they didn't want to change the Flash file at all. Once they published it, they just wanted to change the data file. Now, my client looked at a prototype that was done by their agency, and they just couldn't believe that this was really data-driven. So they called me up, said, "Hey, Jim, is there any way you can take a look at this?" One of the interesting things about Flash is that Swift was an open file format. And we had some incredibly brilliant people that wrote this thing called a decompiler. So you could take the Swift file, which is executable, run it through the decompiler, and you get back a FLAY file, which wasn't like the original FLAY file that the developer used, but it was enough for to go in and deconstruct what happened. So I ran it through the SoapThink decompiler because I was kind of curious as well. I said, if they did that, I think I want to go work for that agency. That's like really cool. And so I noticed that, yeah, they're animating the route arcs, and there is this data inside in this action script on the first frame. But in Flash, you had this ability to do an eval. And if you evaled a string, it would try to give you back a reference to a movie clip in the library that had that instance name. So what they had done is they had hand animated all of the origin destination arcs, and they had given them origin destination like DFW ATL instance names in the library. So yeah, they had data. So from DFW, we fly to all these cities. It would just concatenate those two strings together, do an eval, get a reference to the hand animated movie clip in the library, and then just say, okay, movie clip from the library, dot, go to and play. And then it would animate these route arcs fanning out. But it wasn't truly externally data driven. If you wanted to add a new route, someone had to go into the library, hand animate that arc, and then modify the file or the internal data. And so I was able to prove that. ExpressJet was furious. So, of course, the next thing was they asked my client, can you do this? Well, what do you think they said? Then I get another call. Jim, guess what you just got signed up to do? And I kind of knew this was coming, so I'd been thinking about it. And there's two problems here, at least the way you would look at it from a 50,000 foot level. One, which I think is fascinating because it's underdetermined, and all the really interesting problems in life are underdetermined, overdetermined, they're stochastic, they're multi-objective, so forth. So I love underdetermined problems. And so you have an origin point and a destination point. How do you draw a smooth arc between those 2 points? There's an infinity of them. Okay. So how do you choose one arc out of the infinity that you can choose? Furthermore, the arc needs to be flatter as the distance between origin and destination, but not too flat. And it needs to be more curvy when the origin and destination are too close, but not too curvy. Well, it turns out, this is the nice thing about having a computational geometry background. There's this thing called 3-point Bézier interpolation. If you give me 3 points and a t-value, if you just give me 3 points, there's still an infinite number of quadratic curves that pass through those 3 points. But you can compute a t-value automatically using this technique called chord length parameterization. I know this because my final year in college, Dr. Tennyson, the guy I took undergrad computational geometry from, was nice enough to allow me to be his graduate teaching assistant for his graduate course. So I had to work through all the lab examples, and 3-point Bézier interpolation was one of those lab examples. Okay, I can parameterize making the arcs flat versus curvy. And so it's really a matter of just putting a bunch of sample points up on a screen, making up some origin destination pairs, and putting up 2 sliders and moving the sliders back and forth until you got a set of route arcs that everybody liked. Animating them is easy. That's something called Decaslo subdivision. Yeah, I know, math, blah, blah. Take my word for it. The really interesting problem was, how do you space the, you don't want arcs like right on top of one another. So how do you kind of space them out? But if you space them out, you don't want to trash other arcs. So I took a concept of repulsive forces from physics, and you give the repulsion a pretty stiff decay. And you move these curves, this middle Bézier, there's 3 points that are interpolated. 2 of them are fixed, the origin and destination. The only degree of freedom is the middle point. That sets an interpolation point. It also simultaneously chooses a t-value that the curve passes through the point. So I came up with this spacing heuristic that was based on a model from physics. Wow, we're finished. Okay, great. It's all done in an XML file. So we ran a demo for them. We showed, here's the XML file. It's external to this Swift file. You can go in and you can take arcs out. You can put them back in. You can create new ones. And they did that. And they absolutely loved it. I thought, oh, yeah, man, this is going to be like the best project I've ever worked on. You know there's a but coming, right? Yeah. So I go to Houston and we get the feedback from the meeting and everybody's saying, oh, how they loved it and blah, blah, blah. Well, here comes the but. Out of about 180, almost 190 arcs, there were 4 that were drawn just slightly over water. Now, all I have is a background image. I have basically coordinates. That's all. I have no idea what the background image is. And apparently one person at the company said, well, sometimes we think our customers take these route arcs as a proxy for the actual route flown by the airplane. And we don't fly over water. Is there any way you can change that? So we have this big meeting. And this is a tough problem. The graphic artist says, well, why can't you just recognize where the water is and just not draw it over there? Oh, God, it makes me want to be a graphic artist, right? Well, I'm sorry, I don't know where the water is. And then we had a guy who came up with, I thought, this is what smart people do. This is what people do who just think outside the box. Very smart person said, well, what if we drew a polygon that gave us an outline of where the land was, and we reorder the code so that it somehow doesn't draw a curve outside the polygon? That's not bad. That's thinking. That's a very fundamentally good idea. But it opens up a can of worms. Can of worms like, okay, now I have to do Bezier line intersection, which means I have to do the triangular control cage intersection first. Then I have to iteratively move it till it's inside the line. Then I have to rerun the spacing heuristic. But now I have to have this concept of fixed arcs. And what happens if another arc gets moved back out? Then we still haven't addressed ExpressJet's primary concern, which is they said they wanted a tool that allowed them to control adding and subtracting arcs from the model. And they were also extremely concerned about exposing IP to the same decompilation process that I went to. So instead of thinking outside the box, let's think outside the world that contains the box. And it just hit me. We're looking at this problem all wrong. We're looking at raw data as a starting point and automated route arcs as an end point. That's the wrong way to look at it. We should be looking at automated route arcs as the begin point and data as the end point. So I came up with this idea, well, they need a tool. They only wanted to modify about 4 or 5 arcs out of nearly 190. That's a pretty good record. So it took me about a day and a half. I wrote this tool that would apply the automated route arc algorithm, and then you could go and edit arcs. You could select an arc, and you could bring up that middle Bezier interpolation. You could move it just a little, and it would adjust the arc. Then you have the option of rerunning the spacing heuristic with that arc, and you could make as many arcs as you want fixed, and then rerun the spacing heuristic. They would just regenerate a new XML file. So they got to go in and change those 4 arcs exactly the way they wanted. They could simultaneously go into the same tool. They could add new arcs. They could take others away. What this tool, or this we used to call it a projector. It was a desktop application where you could take the Flash runtime and generate a Windows or Mac executable. They were Windows based, so we did one for Windows. All it generated was an XML file that had the 3 interpolation points. So yeah, instead of having origin, destination, you had origin, middle point, destination. That was all in the XML file. From there, it's just 3-point Bezier interpolation and Ducaslo subdivision. And I told them, okay, I guarantee you, 3-point Bézier turbulation goes back to at least the late 1970s because Dr. Tennyson gave it as an exercise in a graduate computational geometry class in 1981. And he said, this is something I had to do a few years ago. So that goes all the way back to the late 1970s. DeCaslow published his white paper in 1959. There is zero, and I mean zero, IP exposed to the flash front end. All of your IP is in that spacing heuristic, which is behind the firewall. They just absolutely loved it. And we didn't have to go over here and develop a neural network and train it to draw arcs. We didn't have to do this complex draw the polygon work. We didn't have to go through what I called a black hole, where you solve one problem, that leads to another problem, you solve that, and it just drags you down into the black hole until you hit the singularity. Again, it wasn't particularly bright. In fact, I don't even think the spacing heuristic was all that interesting. To be quite honest, it wasn't something that I would say a particular smart person do. But the key to getting a happy client was not thinking outside the box, but thinking outside the world that contains the box. And I would say, in a nutshell, that's been my career. And it doesn't make any difference one of my favorite sayings is, and I think this is still due to me, is that programming languages come and go, but math is eternal. It's always the same math. Assembler, BASIC, Fortran, C, C++, C#, Java, JavaScript, dynamic HTML, Flash, ActionScript 1, 2, 3, Flex, Angular, TypeScript. It's still all the same math.
I had a quick question. So I'm not very good at math. I'm actually pretty terrible at math. um, how would you suggest somebody who has poor math skills get better at math in order to, I guess, flourish in their senior year?
I would just say pick some topic that is of interest to you that you know has some aspect of mathematical sciences. And then that's your end goal. You're never going to get to the end goal in one step, but it gives you something to shoot toward. And then start working backward. Okay, maybe you do some research and, man, this requires some linear algebra. I don't feel great with linear algebra. Okay,
Right.
but maybe I can start with something simple like vectors, and I can just understand how to draw vectors in the plane. Maybe go off and try to relate it to something that you do know in code. Okay, can I write the code for maybe a point or a vector class and get familiar with concepts like length? And just keep working backwards until you get down to a level that you feel comfortable with. Then just one step at a time, keep adding on until you can conquer whatever that goal was that you thought was like incredibly interesting. But break things down backwards to their most fundamental elements, and then work on being able to place those fundamental elements in something that appeals to you. Like my first big job out of college, when I was writing assembly language, I worked with this brilliant hardware engineer. His name was Steve Wallet. Steve is an incredibly bright guy. I mean, he could do hardware architecture like nobody's business, but he also wrote assembly language. Now, he was not a math guy. He had the same problem. Matrix algebra hit so many verticals that we worked with. Now, I love to go to the whiteboard and, I'm the $6 million equation writer. No, 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 no. He couldn't relate to that. But what we found very quickly was that so much of the procedures in math have equivalents in code. Like all of this stuff we were doing mathematically, I could write as Fortran do loops. If it was a vector operation, it's a single loop, one induction variable. If it's a matrix operation, it's a double loop, 2 induction variables. So if I could write things in Fortran do loops, he could understand the mathematics, even though he couldn't understand all the equation stuff. That didn't make sense. That's what tends to turn a lot of people off. Think more about how you would express those equations and those concepts in some coding paradigm that is familiar with it. Start with the lowest, most fundamental level and just work your way up from there.
And yeah, so I guess I could take it back to basic math and build it up from there. Because like I said, I don't think I got past algebra 1, algebra 2. I think I took a week of geometry and then I quit.
Well, you've got quite enough background to get started on a very wide variety of things. It's just a matter of how much time do you want to spend on it, and where does it take you. But you can do it. Just don't get caught up in all the math and the equations. It's just like, this stuff comes into your eyes and
Yeah.
it just goes quickly from your eyes into mental block.
Yeah.
So get away from all the equations and stuff and just start thinking like a dot product between 2 vectors, right? You can write that in a loop. So equate it to something that is more familiar to you, and then just work your way up from there.
Okay.
I do have a question, Jim, about kind of like your hobbies outside of the world of data. I know you're a little bit into volunteering.
Yeah, I've done quite a bit of I'm currently a volunteer for the Carrollton Police Department, the Denton Police Academy, the Carrollton Fire Department, and the U.S. Forest Service. I kind of have this Action Jackson alter ego. There was a point in time, you go back into the early 2010s, when we made that big transition from Flash and Flex being the dominant front end technology to kind of moving backwards for a while, with HTML5 and jQuery and Angular 1 and all of that. There was this period of time that there weren't many consulting opportunities open for a guy like me. I mean, people are just figuring out how could we take the stuff that we did in Flex 5 to 10 years ago and just get it to work in HTML and jQuery. You don't have needs for specialists and mathematicians. It took quite a while for that whole environment to catch up to where I could start getting, regular consulting work again. So I actually went off and got back into the private security business. I went into executive protection because that's great, permanent part-time work. I worked as a bodyguard. I continue to this day to train with the Force Recon Marine. I did all of my close protection, firearms, weapons training with him. He was also the guy who taught me search and rescue. I now do search and rescue as a private contractor, and I specialize in wilderness night operations. So I'm one of the few people who will go out on behalf of the friends and family of a lost person or persons and search for them at night. I mean, most all volunteer activities, they shut down at night. Well, night is when I get started. Yep. So that's what I do in a lot of my spare time. I also have a YouTube channel. I do product reviews from a search and rescue perspective. That's just something I stumbled into. It took off, and so I just kept running with it. And so far, I'm still running.
Have you ever thought about teaching? I mean, you have a wealth of knowledge.
I have thought about it, especially since, you can kind of tell from all the gray hairs here that I'm at that point in my life where I have like this many years behind me and maybe this many years ahead of me. And so on the one hand, I have thought about teaching, but I do want to try and leave something permanent behind. And that takes us to a project that I know Kevin has helped with, and I really want to call him out and give us some props. I've probably got at least 350,000 lines of code just laying all over it. Some of it is an old yellowed paper, Fortran printouts, other stuff I've kept up with electronic, but it's in all these various languages. And I want to get all of this stuff into one comprehensive open source library. But it's going to take an incredible amount of time to do it. And, I'm living on a very small fixed income right now. And so I have to do occasional consulting gigs and other stuff to make ends meet. So I've kind of made this a crowdfunding project. So if you'll help me out a little, I'll do a whole lot. And it's called the Amir library. I'll make sure that Kevin puts the GitHub out. There's a ton of code in there right now. It's in TypeScript because I found that TypeScript is a good language to reach out to a variety of people. It's something that modern web developers, modern full stack developers can read. However, it's also something that I've given to C and C++ and C# programmers, and they can pick it up almost instantly. Java programmers can read TypeScript. So it's a great way if you're describing an algorithm or a process to appeal to this very wide audience. So my goal or my hope is to one day, maybe instead of teaching and influencing a small group, I can somehow get this massive body of code in pristine, extremely well written, well documented TypeScript, and that's something that the whole world will have as long as you have GitHub.
Are there any competitors for your library that you're writing right now?
What's that?
Are there any competitors for your library that you're writing right now? Like anything that's equal to your library that's on GitHub?
I don't know. Maybe in part. I mean, so for example, you take data structures. Okay, I have a full data structures library. Is there another data structures library out there in TypeScript? I don't know. I mean, honestly, I haven't looked. I tend to use my own because I've just been using them for so long. And every time I gravitate to a new language, well, I got to migrate this library over and that library over and blah, blah, blah. But my library has AI. It has A* for waypoints. It has an expression engine, a decision tree. It has statistics. It has math. It's going to have, just this massive breadth of stuff that I think the only competitors would be something like a professional third-party library like IMSL or NAG or something like that. But in terms of open source, I don't think so. But don't take everything I say as being completely true. If there is a library out there, let me know so I can maybe take a little of it. Remember, good programmers write code. Great developers steal.
Did you have another question, Roger?
Yeah, I was gonna ask, why do you choose NX as your monorepo for your monorepo development? Like there are other ones.
This is something I happen to be familiar with, and so it's one of those paths of least resistance because I guess being associated with Angular for some period of time, you get exposed to things in the Angular ecosystem. And I started using NX in a couple projects. And so, fundamentally, I'm not a developer. I'm just, another dumbass out there trying to, create stuff. And so, like all the other dumbasses, I just gravitate to something that's quick and convenient and familiar. That doesn't necessarily mean it's the best solution. It's just a solution. And I think a lot of other people out there are familiar with NX. So, it's kind of like the TypeScript thing. I talk to people about monorepos, and they all talk, NX. Okay, fine. I guess maybe that's a way to go, but it doesn't mean it's the best way to go.
What are the kind of skills that you're looking for when you're asking for developers to come and work on your library?
I haven't actually invited anybody to work in yet, but I mean, honestly, if there is an area of mathematical sciences that someone is familiar with and they want to contribute, by all means, look me up. I would say uh, partial differential equations. That's like one of the one areas in high performance computing I never really got into. I mean, I know that multi-grid exists, but I never wrote like a multi-grid PDE solver. So, there's going to be this huge hole. If I ever get to complete the library, there's going to be this huge hole for, partial differential equations. Just, some area of applied mathematics that I don't have a lot of experience in. That was just like the first one that came to my mind. But really, in particular, if someone has expertise in a particular scientific or engineering or business discipline that would give the library um, greater applicability to users in that area, I would find that to be very valuable.
No.
As well as somebody with a general math and programming background that could take things over when I'm at that age that I'm in the nursing home, like that. And I'm not capable of tapping away on the keyboard anymore. Maybe you young whippersnappers will have thought controlled editors by that time.
So, can you tell us about some of the intro? Oh, go ahead.
No. I was going to ask about some use cases for the library, but I also remember you mentioned an Angular. I'm also an Angular developer. Not
Cool.
quite experienced as Kevin, but still learning. So, what are some cool projects you've built in Angular, or did you just?
Probably the one that I liked the most was the Hilti scenario designer, because it was so analytic and computational geometry intense with just a tinge of AI. It was very cool. So the guy who came up with this idea was like, this was the most brilliant business idea I've ever heard of in my career. And it has to do with firestop. And so if you build a wall, you can't just build the wall, especially if it's a commercial building. You have to firestop the wall, which means the wall has to be certified to hold up to temperatures of so many degrees for so many minutes. And that problem is made worse when you start punching holes in the wall and fitting pipes through and wires and all this stuff. And so that process is done by what's known as an approval. An approval is this incredibly complex document. It can be, 25 pages double-sided with all of these diagrams. And, the fire marshal doesn't walk in and say, well, let me look at that. Okay, yeah, do some measurements here. Okay, yeah, you're good. No, the fire marshal walks in and says, okay, I see a 3 single penetrations for copper pipes here, and you have a big hole you cut in, and the plans say you're to have a cable tray in there and some more pipes and blah, blah, blah. Give me your approval. The approval document is created usually by some governing agency, city, local, state, country, and it's different from EU and America and so forth. So the fire marshal, before you're going to be able to get that wall signed off, show me your approval document. Can't do an approval document. You have to take the design off, send it to a consulting engineering firm, pay mucho dinero, and get what's known as an engineering approval. So what they wanted to do was be able to have people design these wall penetrations interactively, then over here somehow take the constraints out of multiple approval documents, then associate approval constraints with a design. And while you're designing, if something gets too close to a wall, then you should be able to somehow mark that as being an invalid spot. And if you got through and you weren't quite there were 2 questions. One, for the particular approval that we have, can we somehow change things to make it work without approval. That's where the AI piece came in. So there was a lot of analytic and computational geometry and being able to allow people to drag and drop and move around. And there was a lot of game-like stuff, recognizing collisions and so forth, in order to be able to interactively draw these fire stop layouts out, and then somehow try to get it to match to a particular approval. Now, the follow-on problem was, if I have this small universe of approvals and this layout is not working with one approval, could I somehow go look through this small universe and find an approval? So that's probably the most interesting thing that I ever worked on in Angular, because it was so interactive, geometry, intense, and then it had that little AI aspect. It was like really cool to be able to show someone a demo where you move all this, it's not quite, and then you click a button, it goes, and it moves everything into place, and now it meets this approval. That was probably the most interesting I've worked on in Angular.
Yeah,
it probably had more to do with Canvas than anything else.
So yeah, you kind of mentioned your volunteer work and search and rescue. Do you have any interesting stories there, or with bodyguarding?
Actually, most of the bodyguard work I worked on Advanced Team and Intel. So I would do things like go to the restaurant before the principal ever got there. And I'd, look over the layout of the restaurant, note entrances, exits, what the layout of all the tables were, and take pictures and do a detailed examination of all the ways you could move around. Think about scenarios if someone was going to try to come in, and principals aren't necessarily worried about getting shot. They're just as worried about getting embarrassed. Like one of the things we used to train for was the concept of, let's say you've got a principal, he's been married to his wife, 30 years, he's very well known business person, but you don't want to hurt him, you want to embarrass him. Sometimes embarrassing is much better than hurting. So you have this beautiful woman walk in with a classic low-cut dress, and she just walks up to the principal's table and leans and says, "Oh, John, I haven't seen you in so long," and blah, blah, blah. "Oh, I'm sorry, you're not John. Oh, I'm sorry, I made this terrible mistake." Well, there's somebody sitting at a table over here, and he's got this little camera, and he's taking pictures of it, and then all of a sudden that stuff's out on social media. So the damage has already been done. So I would think about scenarios like that, and then I would be in the restaurant when the principal and the team actually came in. Might be a hotel lobby, it might be a meeting place. And I'd be there on my computer, because I'm just this, I look like a dumbass. I put a cap on, I look like a real dumbass. I look like I belong in a restaurant typing away on my computer. Do I look like some 6'4" X SEAL Delta type of guy? No, I just look like I belong there in the restaurant. And so I'm typing away, I'm doing something, I'm calling people, I'm texting. What am I doing? I'm sending real-time intel to the detail lead. So that's the type of stuff I did. I could be in a conference, and I could have my business dress on, and maybe it's a conference on some topic, and I'd go out and learn enough about that topic to talk about it, and I'd be wandering around the conference and be talking to people. But what I'm really doing is I'm looking for people who are, maybe they're eyeballing our principal. I don't like eyeballing, or there's something's off about their body language, or I'll strike up conversation. Hey, what do you think about old Bill Phillips and XYZ Incorporated? I mean, if I could, okay, that's something we need to watch out for. And so, we'd have a variety of signals like in baseball, not that bad, but I might do something like I'd scratch the back of my ear while I was talking to this person. And that's letting the detail lead know, if you see this guy get even 10 feet close to your principal, you need to cut him off. So, yeah, that's the type of stuff I did. maybe every now and then I'd go pick the principal's wife up at the airport, get her checked into the hotel, take her out to North Park shopping mall, make sure nobody steals her bling bling, take her out for an early dinner and make sure you get her back by 8 o'clock or something like that. So yeah, a lot of times in the executive protection business, a lot of us are just over glorified valets.
So what about the search and rescue? What is that like? Searching for somebody at nighttime.
Interesting. Ironically, most of the people that I've been able to help, only a couple have been out at night, and they were fortunately very easy. They weren't like deep lost. They were just turned around, trying to get back where they were, and they could be discovered very quickly. So, like, one of the things I use is this 140 decibel hyper whistle. It's great for deterring animals as well, because that's one of my biggest risks at night is animal encounters. I do a lot of work at the LBJ grasslands, and there's everything out there. We got feral hogs, coyotes, bobcats. I do believe we have at least one mountain lion out there. There was a product review I did where I went way out to the most northwest edge of the grasslands, came around Eureka Lake. I was filming a segment. I just smelled it. I've had that smell before. I knew that was a mountain lion.
Mm.
And I came by a few days later during the day and filmed another product review. Went across the same route. That's when I picked up the big cat tracks. So I know they're out there. I don't need animal encounters. If I have a hostile animal encounter, they're acting on instinct. I can't reason with them. The only thing I can do is put the animal down. I don't want to do that. In addition to, I don't want to shoot animals. What do dead animals bring? More animals. It compounds a problem. And so I want to deter them. And this hyper whistle has been a great way to do it. Well, of course, people can hear that. They hear the whistle. That is like, okay, there's somebody out there. Then they start yelling and screaming, and able to pick up on that. Those are what I call the easy type of rescue. Most of the people I run into have been during the day, and they're really lost, and they are in really bad shape. And I'm out doing a mapping or a land nav accident. I run into these people by accident. There's this one lady I ran into. In search and rescue, you think about, well, you've always got to consider the physical state of the person. And yes, that's true. But before that, you may have to deal with the psychological state of the person. This is particularly the case if you're searching for lost kids, because lost kids are going to be scared out of their mind. And they see me, and I'm like the predator. I'm one ugly motivator, and I've got all this gear on and this light and stuff like that. They probably think I'm the boogeyman. That's why if I ever go search for a young child, one of the first things I'll do is I'll ask the parent, can you give me something that belongs to them? Like, yeah, they've got a jacket over here. And can you tell me something about them that only you and the child know? Like, I did this one scenario. I was searching for a girl named Sunitha. And so one of the things I asked Sunitha's parents were, what are some of the things you guys love to do? Well, she loves to go out playing soccer every Saturday and then go out and eat at Chili's afterwards. So if I run into Sunitha, which I did in this training scenario, I illustrated in the video how one of the first things I would do is just talk to her in a very gentle voice and say, man, your parents are so worried about, I was talking to them. They were telling me how you love to play soccer every Saturday and go out to eat at Chili's afterwards, the psychological state. So I ran into this lady, and she was at something. Well, there are these things that they look like walkable paths, but they're not. and she was on one of these, and it was following a fence line, which is normally a good thing to do. But I knew that if you followed this fence line, it leads only to the dark side. And she was clearly in an agitated state. She thought that I was stalking her, and she kept screaming, "Get away from me! Get away from me! Don't hurt me!" And one of the things they teach you, and I like to when I do teach other people about SAR related topics, is that there's 3 words that you always want to try to use. Maybe not in this order: help, safety, rescue. Ma'am, my name is Jim. I'm with Search and Rescue. I'm here to help you. I want to get you back to safety. And repeat over and over and over. This lady was so out of her mind. She was clearly dehydrated. I think she may have been on the verge of hallucinating. She had been out and lost for a very long time. She was beyond panic. She was beyond disorientation. So I had to try something a little different. Says, "Ma'am, look, I'm not here to hurt you. I told you I'm going to try to help you. I want to lead you back to safety, but I can't do that if you won't go with me, okay? I can't force you. I'm not going to abduct you, but I'm going back to Valley View Campground." That was the nearest campground to where we were. That seemed to strike a chord. I kind of noticed the change in her eyes. So she probably parked at Valley View Campground. "You're welcome to follow me, but I'm not going to stand here and just keep saying the same things over and over." So I slowly started walking away. She slowly started following me. Finally, I let her catch up with me, let her get some water, let her get hydrated. She had gotten so lost. And here's an interesting thing. Of the probably 20 to 25 people I've helped out at the LBJ grasslands, you know what the large majority have on them? A map and a handheld GPS device. And yet they're as lost as they can be. This GPS is a mechanical device. I ask people who like to navigate by GPS, when was the last time you tried to go somewhere with Google Maps or Waze and it sent you all over everywhere? It happens. You can lose satellite connections. There's this concept called KP index. GPS can be interfered with. There are other things like on an outbound, you don't understand. I'm moving this way, and there's another trail that kind of merges in like this, and I don't see it. Well, when I'm coming back, all of a sudden I see that I've got this fork. Which way do I go? Well, I'm navigating back to my most recently set waypoint. Where does the arrow point? In the middle of the fork. Which way do you go? They take the wrong way and they get turned around, and that's what had happened to this lady. And so she was telling me about the GPS. I'm trying to get back to Valley. Ma'am, I'm taking you back to Valley View. And as I talked to her, she kept saying GPS. Well, finally I had to ask her, "Where's your GPS device?" "Well, I heard something in the trees, so I threw it at him." Like, wow. But amazing, I had enough water to get her hydrated. I also carry a life straw container and an extra life straw if it's necessary to get water from other sources. Thankfully, I had enough on me to get her hydrated, and I kept telling her, "We're heading back to Valley View. We're going to catch the blue trail here." I just told her every step of the way how we're getting back to Valley View. And thankfully, she was able to walk all the way back to Valley View once we got her hydrated. That's probably the most interesting situation I've ever run into.
All right, guys. And y'all have any other questions? How about you, Jim? Did you have any closing thoughts? We're kind of approaching the hour and 30-minute mark.
Oh my, anybody that listened to me for an hour and 30 minutes, pat yourself on the back. Wow. No, I'll just close with this. Your identity, your sense of value is inside you. It's not reflected by the framework you use, the language you program, or anything else. Find that inner sense of value and foster it. Because whatever language, environment, framework you're working in now, 10 years from now, it's probably going to be different. With me, that inner value came from the application of mathematics. Find that. Don't worry about what other people think. Just keep fostering it and moving forward. And final thought, I'll close with my initial thought. Don't just think outside the box. Think outside the world that contains the box.
Yeah, we definitely appreciate you for coming on. We'll have to definitely get you back and explore it because you have a ton of knowledge, and we really need to
Well, I don't
document
know
it.
about the whole knowledge thing. Like I said, I'm kind of a dumbass, but I've got a lot of experience. I guess that counts for something.
Yeah, most definitely. Yeah, we love to have you back. But thanks for stopping by today.
All right, no problem. Thank you.
Thank you.
Thank you, everybody, for tuning in. We'll catch y'all next time. Y'all have a good one. Good night.
All right.